Okay, so as always, the code for this question will be in the description, but if you want the explanation, you can continue watching this video. See, this question is easy as always. I'll explain to you how. But what is the question first things first? If you break the question down, what they basically told you is they'll give you two strings, two words. And your job is to find out whether you can convert the upper word into the lower word using either one operation, the first A operation or B operation, or use both, or you can't use neither of those to change this into this. So I'll tell you first thing first, what are the operations? See, let's take A, B, C, D and ABC. Now you have to convert ABCD into ABC. For that, I think the word was some affirmation or something. I forgot. I don't remember. So let's say I'll name this operation A. Okay. Remember this A, okay. I'll get back to this A later. What operation A states is that given a particular string A, B, C, D like this, a word, in this case, what you can do is remove one letter from this word. Now in this case, you can remove the letter D, right? Then you'll get what you want, which is ABC. So now we have ABC. So you can use the operation A to get ABCD to ABC. Now there is another operation that you can do. Let's call this operation B. Which basically states that given, for example, this is the word that you're given, this is the word you're supposed to change it into. Given two letters in that word, you can swap those two. In this case, it's B and C, you can swap those to C and B. This is operation B. Why did I name it A and B? I'll tell you why in the end. So, given these two operations and the word you are given and the word you're supposed to change it into, can you do it using these two operations? That's it. Or you can't do it. If you can't do it, there's another way to write it down. I think it's called need tree. Yeah, my memory serves me right. It's need tree. Let's take a case where we can use both, which is, so in this case, what you can do is, first things first, easily, for both of them, first you can remove both B from both and you can get OTH. Now you convert this into this. Of course, you can swap them multiple times, any number of times, but you have to perform the operation, which is H to T. You can swap it, which will give us OHT, and again H to O, which will give us HOT. And we have the word that we need from this to this. So that's the case. If you can't if you can't convert it to the required word using any of these or both of these operations, then we can print that we can't perform it. They gave you this format and how to do it. What to do now is the question. See, the only trick is with finding out a specific case, which is either should we use operation A or should we use both operation A or B. This is the only point where we need to find out. This is the only part of the code which I'm going to explain to you properly. But before that, I'll explain to you how you are supposed to find out if you need a tree or something like that. If you can't, first things first, let's look at this thing gradually. First, how can you not find it at all? Even if you use both A and B, you can't find it. You can't find a way to get this to this. When is that possible? See, in these operations, you can only see that you can either remove elements or you can change the existing elements. Which means that you can't add new elements in. Which means in these given letters, given words, if the required word that we want has a letter which is not in the given word, you can't convert this thing no matter how many times you apply operation A or B, and both of them at the same time. So first things first, take a map, find out what are the elements in this. If they match, I mean, at least if all the elements in that word are there in this word, that means that okay, if A is more than once here, if it's like A, B, C, sure, fine. If A is more than once present in this word, it's fine. But if A is not present at all, if it's just B and C, then we can't convert this to this because it has A. So should at least have the minimum number of elements that this word has. So basically means that all the letters in this word should be present in this word. The exact same frequency of each word, an exact number of words, and the exact variations of all the words. If that's not there, then print it's not possible. So okay, we covered not possible part. Okay, so now okay, this which means that we'll get to the next tree, which is it's possible. But how can you know that we have to use A or B or both? First, let's look at B. Okay, swapping these elements. Swapping, what will happen is, in case of swapping, we can swap a word, any letter, two letters, any number of times. So at the end, if no matter how disfigured this word is, you can swap them infinite number of times. You'll get this word. Not infinite, in a finite number of moves, you'll get it. The point isn't that. The point is, when does this case occur? When the frequency of number of letters in this word is exactly equal to the frequency of letters in this word. In this case, A and B, A occurred once, B occurred once, and C occurred once. So basically, in this case, the frequency is exactly the same. In the previous case, you want to check it, you need to check whether it is at least as much as this. At this point, no, not at least. It should be exactly the same. There should only be one A or one B or one C. If there are two A's here, then there should be two A's here. There are three A's, 10, 10. That's it. If that is the case, if the frequency exactly the same, then array is the only thing we need. I mean, not array. The operation B is the only operation we need to solve this thing, because if you use B, you can swap those elements any number of times, you'll get this thing. You don't need to remove any element because the elements which are there in this word is there in this word. So everything is there. We just have to swap it, rearrange them. You don't need to remove anything because it's essential. If you remove this, you can't make the word again. So operation B. Okay, now operation B is done. Now we jump on to, okay, no, B is, without B we can't do it. It means that maybe this word has two A's and this only has one A. In those cases, now we're getting to the deeper part, which is using operation A, at this point both. Now how do you find this out? See, the thing is, in order to find out whether we need to use operation A, first things first, both will be the last. First, let's see, okay, B is not possible, right? Let's see if we can do this thing using only A. If we can use just A, how are you going to do it? See, take these two words, take the frequency of them, you'll get this. It's operation B. No, it's too much. At this point, what you're supposed to find is, okay, for example, take this, both and hot. That's a nice way to start this. This is a nice way to start this thing. You have the exact number of words you have, but an extra B. Now, I have an idea. What you'll do is, you'll write this like this. A, B, C, D, E. Okay, before you get into both and hot, we'll talk about this. Okay. Now, in this case, operation A is all you need because ABC is there in this. We just need to remove this A and this DE. But no, let's take it like this because this is a little too simple. It's D and C. Okay. Now you may think maybe then we need both. No. If you remove A, and D and E, what you will be left with still is A, B and C. So in this case also you need just operation A to solve this thing. So what you basically have to do is, first things first, find out in this string are the words is the word exactly aligned in this or manner, which means that basically we need to find this sequence in this sequence in such a way that is it in the same chain of order. What I mean by that is, in this word, does there exist a letter A followed by a letter B followed by a letter C? That's it. It's not about whether they are together or whether they are separated by another letter. Is there a letter in this word A? Yes, there is. Here, don't take this. Take this one. A. Okay, after A, we'll go through each and every one of those. Since it's A, now we are at B. Is there a letter B? Yeah, B is there. Is there a letter C? Yeah, we'll go here. C is there. If A, B, C is there, then we can do this thing only using operation A. Because that chain of letters, the exact sequence of chain of letters is present. The sequence is present in this word one. So you don't need to modify anything. You need to swap them, which is operation B's purpose. If this is the case, sure, operation A, you can print it out. And if it's not the case, you can just print both, because in this case, maybe say it's C. C and B. In this case, A followed by B followed by nothing, right? If you go through the same logic, A is there, so you'll go to B. B, you'll find B, yeah, you'll go to C, and you just get out of the loop. Now, since we didn't find C here, this basically means that this sequence is not there. But since we went to this tree, we know that it can be solved. First things first, since we eliminated the possibility there, the first one, whether we can use it solve it using operation A or B. So in the second one, we checked whether we can use it only solve it only using operation B. And in the third one now, which means that no, this can be solved, but not just using B. Now we checked whether we can solve it only using A. No, it can be solved only using A, which means that then it is both. So using the decision making tree, he can get to the both conclusion there. If it was a previous one, then okay, we can only use it using operation A. Since the sequence is there, then according to the decision tree, you can print operation A. Basically, this is how you'll approach this thing. Don't forget the fact, don't use this needle in a haystack sequence where you find the exact structure, because see, in this case, ABC, in that previous one, ABC was not there in the exact same structure. A was on one part, B was on one side, C was on the other side. That's what you're supposed to be careful about. Don't look for the word, this word here. Look for the sequence of letters in that particular order, and you'll get the answer. And the next thing you're supposed to be careful about is the words that they ask you to print. I believe that the operation B was array. I told you why it was operation B and A. Operation B, I guess, was array, and operation A was ascension or something. And in that, I mean, usually when we write ascension or something, shun, we write TION, right? What do you write? We write it as TION. TION. In there, it was TON. What I did was I read the word. I was like, okay, ascension, ASCN TION. TION. Failed in the first test case. Why? Because it was TON, not TION. One common thing I'll suggest everyone do is, if you can copy paste it, just copy paste it. Even if you know the word, it's best to just copy that particular thing. You put the scroll it, and you paste it. Okay, then you can be sure, because they told you they gave the exact thing. You paste it as it is. You didn't write it down on your own using your own memory. Second thing is, if you can't copy it, like in some exams or some cases like that, I'll best suggest you to just carefully look it and write it down, and carefully write it down from there to the code. That's another point. So question itself is easy. So yeah, that's the only thing I can explain to you. Thank you. So that's it.